So what did you think? It was fair, except for the fancy trig problem. There were like 100 fancy trig problems. Yeah. Screw it up. Nice job. It's the best quiz I ever had. Could have been worse, but not the best. It's okay. That's good. Yeah, I think if you guys like the quizzes too much, it's not. It's kind of worse in a way. I'm gonna move that back so this lines up. There we go. It's a separate layer. Okay, here we go. So we are going to chat about. What are we talking about today? Related rates. We're talking about related rates. So here's the thing. Related rate. What are related rates? You took notes on them. What are they? It's two rates that are related. Yeah. No, simply put, it's two rates that are related. Now, it's usually you can't really use the definition, the definition of something. You can't use something in its own definition. But in this case, I think it's clear enough. So, if we want to find, hold on, I got to grade some. Okay, so you need to both sides of what though?
Of x and y.
What do you mean? What are x and y?
The two variables
that you want to. So if you want to study the rate of the relationship between the rate of change of two things, what do you need first?
You need
an equation that relates them in the first place. Exactly. Building that equation is usually where the difficulty lies. The differentiation is usually not the hard part. It's building that equation. Sometimes the equation is known. Sometimes the equation is given to you. Not always, though. Not always. Okay, so here's this example right here. It says, a balloon is being filled with air, so its volume is increasing at 100 centimeters cubed a second. A balloon is being filled with air, so its volume is being increased at a rate of 100 centimeters cubed a second. How fast is the radius of the balloon increasing when the diameter is 50 centimeters? Now, here's the thing. What shape are we assuming this balloon is?
circular.
A sphere. A sphere. We're assuming it's a sphere. We're assuming it's a sphere. It's not necessarily the case. Most balloons are not spherical, but let's assume it's a sphere. This models it fine. Now, we're trying to relate. First, you need to identify what are you trying to relate. You're trying to relate volume and radius. Do we actually have, for a sphere, a formula that relates volume and radius? Yeah. Volume in terms of radius is equal to what? 4/3 pi r cubed. Exactly. Volume in terms of radius, and you can write it as v if it helps you that way, v of r, either way, is 4/3 pi r cubed. That's correct. Let's take the derivative of both sides with respect to what?
T.
d dt. We're doing d dt of both sides. So if you take the derivative with respect to t of v, what are you going to end up with? dv dt, the rate of change of volume with respect to time. What rule are you going to have to use on this?
Product.
Nope.
No,
the power rule, the first one we learned. So it's going to be 3 times 4/3 pi r squared times what? Times dr dt. Yes, exactly. So what does that simplify to? dv dt, the change of volume with respect to time, is equal to 4 pi r squared times dr dt. So this question is asking, what is, how fast is the radius changing? So what is that? Is that dv dt? No, that's dr dt. So we want dr dt. Do we have to solve for dr dt first before we evaluate it? Meaning, do we have to isolate dr dt first? You don't have to, because we can just plug in values and then isolate it.
Yeah.
It's usually easier to plug in values and then isolate. When the diameter is 50 centimeters. Okay, so
you're looking at a point.
So when the diameter is 50 centimeters, so this thing is getting bigger when the diameter is 50 centimeters, but we have this in terms of the radius. So when the diameter is 50 centimeters, that means r is 25. So, oh wait, we want how fast the radius is changing, so we don't know, so dv dt yet equals 4 pi times 25 squared dr dt, right? But we want to solve for this right here, correct? What do we still have in there? What do we need to get rid of? dv. Do we have dv dt? Yeah, what is dv dt? 100 centimeters cubed per second, right? We have that, so we plug it in, and what do we end up with? 100 equals 4 pi times 25 squared times dr dt. Now you just have to isolate dr dt. This is dr dt in that specific instant when the radius is 25 centimeters, so the diameter is 50. So we end up with 1 is equal to 4, the 4 cancels, and so does 1 of the 25. So you end up with pi times 25 times dr dt, because 4 times 25 is 100. So dr dt, the one we're looking for, is 1 over... Is that a really big number or a really small number? It's relatively small. Does that make logical sense? If you have a big sphere and it's getting bigger, and you increase the radius by an inch, what happens to the volume?
It goes up by a lot.
It goes up by a relative larger number, right? What's the units on this dr dt? Centimeters what?
Per second.
Per second. You can wait till to put the units on the end, but you need to put the units there. We don't have too many units to deal with. We have velocities, we have accelerations, we have change in volume, change in distance. You can put it in at the end. The volume and the radius, the rate of change of volume with the rate of change of radius. So what did we need to do? We needed to find a relationship between the two.
Yeah.
In this case, did we have an equation? Yes, we did. If you didn't have that equation, could you do this? No. And here's another kicker. Do you have any idea where 4/3 pi r cubed comes from? What? Basically, have you proved that?
We've never proved it.
No. You have it.
4/3
4/3 pi r cubed. We will prove that in the second half of this class.
Yay.
You need integrals in order to prove that. But it's a rather straightforward proof, relatively speaking. It's kind of cool, though, because what number gets generated when you find the area there? Pi. It's actually because there is a relationship between the volume of a sphere and the area of a circle. The area of a circle has pi as part of it, so therefore that's how pi gets dragged along. I find it interesting when these numbers get generated. It's another way to generate pi. I mean, for example, here's something you don't even know yet. Probably was pi r squared is the area of a circle, right? Pi r squared. Why? Do you know why? No, you probably don't. Maybe Tony does. Tony tends to know a lot of stuff, so maybe Tony does. Nope, not make an equation. Picture. Draw a picture. Please draw a picture. You have a vertical... Yeah, I understand. It's in my notes, but I'm going to draw it again. So here's the wall and the ground. Okay. So what's leaning up against it? A ladder. And what are you assuming about this ladder?
Perfectly.
It's perfectly straight, okay?
And kind of beveled edges that just
change. Exactly. Yeah, exactly. Right. Okay. Well, maybe those are the corners right there. Maybe that's like like this. Okay. So there's your ladder. There's your ladder. In a frictionless environment. That's great. Well, no. Okay. I'm not going to draw the steps. So that's the size of the ladder. Okay. So do you understand what's happening here? It's sliding down, and it's also assuming that you're maintaining contact with both the wall and the ground. Okay, so it's saying that this is 10 feet long. And it's saying that if the bottom of the ladder slides away from the wall at 1 foot a second, so it's going away from the wall at 1 foot a second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? So what do we need to relate together here?
Distance from the wall and distance down the wall?
Yeah, that's a great way to say it. So we need to label. So we drew a picture. Our second step is going to be to label things. What do we need to label? How many variables do we need? 2 of them. What's one variable we could use? Well, no, we're not going to do differentials yet. We need x and y. And usually speaking, this is the x distance, and let's call this the... Please, you can switch them, but for me, please, because you love me so much, can you pick labels that make sense? Like, could you switch x and y here, and you can still get the right answer? Sure, but generally speaking, yeah, pony, dog, right, exactly. But vertical distance x, horizontal distance x, vertical distance y.
One quiz, people are just going to put pictures as their variables.
Okay, so now we need to relate. What are we relating? We need to relate x and y. So if we're going to relate x and y, what do we need?
An equation.
An equation that relates the two. Exactly. Can someone tell me now what the equation is? No, we're not doing area. What do we know?
We know
Pythagorean theorem. So what do we know? Yeah, x squared plus y squared is equal to 100. Exactly. So now, what do we do? Differentiate with respect to t. So we're doing d dt. Exactly. What does 2x become? dx dt plus 2y dy dt. You're going to do this so many times, okay? dy dt equals what?
0.
That's really key. I will see that 1 out of 20 times. People, oh, it's 100, and then everything doesn't work. Okay, so what do we now know? We know x dx dt plus y dy dt is equal to 0. So now we want, which one do we want? We want dy dt when what? We know dx dt is equal to what?
6.
No, 1. And we want it
X
when
equals 6.
x equals 6.
Yep.
So we have 6 times 1 plus y times dy dt is equal to 0. So we still need what? What do we still need?
Y.
We still need, and I got to stop highlighting whole things. I got to, because the printing out doesn't work, I found. It does work, but most printers have an issue when you try to do colors over
But
colors.
then you actually use the Pythagorean theorem.
Yes! You need y when x is 6.
So 6 squared plus y
Exactly.
squared equals 100.
6 squared plus y squared is equal to 100. So y squared is equal to...
Square root of 74. Or 64.
64, so y is equal to
8.
8. So we have 6 plus 8 dy dt is equal to 0. So dy dt negative 3 over what? 3 over 4. It's equal to negative 3. What's the unit? Feet per second. Now, numerically, the last thing I want you to do, what's the last thing you should theoretically do if you have enough time on any question?
Prove it.
Check your answer. Yeah, and I guess that's the same as proving it. Check your answer. Now, here's the thing. Sometimes you don't have enough time to check everything, especially on the AP test, but check reality here. Is it negative? Is that okay?
Yeah.
Yeah, it's going down. And does it seem like it should be negative 3/4 is a relatively a correct answer? Yeah. What kind of answer would set off alarm bells? Maybe a positive answer or
30, 100.
a billion.
Breaking the sound barrier going down.
Yeah, exactly. Yeah. Wow. Wow. You need a rocket pointing downward, okay? Man, this parachute's a knapsack, like that. Check your answer.
Ladder.
And then at least with reality, okay? At least with reality. You will see this type of question all the time. All the time. Deep thoughts for this. This is going on the record. The cars are traveling forward. Awesome. So we have x and y. And what do we know here? And this is the distance between them. Correct? It says, what is the rate? At what rate are the cars approaching each other when car A is 0.3 miles? At what rate are the cars approaching each other when car A is 0.3 miles away and car B is 0.4 miles from the intersection? So we need to relate those three things, x, y, and d. What's the relationship? X squared plus
Y squared equals D.
Squared.
equals d squared. Now here's the thing. They're all three of those things are changing, right?
Mm-hmm.
Do you agree with that?
Yeah.
All three of them are changing. Now here's the other thing. We're assuming that this intersection is perpendicular. Just another thought.
Perfect intersection.
Perfectly. And the paths they're taking are straight lines.
And frictional scars.
Well, no, maybe there are friction. They're just going at 50 miles an hour, and they're never going to stop. They never slow down.
There's no
Nothing
stop
ever.
sign at this intersection.
Exactly. Okay, so if we want to differentiate this with respect to time, what do you end up with? And then you divide it by 2, and I'm going to skip
I
some
have a
steps.
question.
Yeah, go ahead.
Should we try to avoid using D in our equations when we're taking
Yes!
derivatives?
That's a great point. I like that. Good job. Hope that's on the record. Yes, it is. Let's avoid using D because D seems like a bad idea. So how about H? H is fine. Yeah, DT? Yeah, nice. So you end up with x dx dt plus y dy dt equals h dh dt. Yes. So we want, which one do we want? We're looking for dh dt, right? So we need to fill in all of the other ones. And we actually can do that pretty easily. It's when x is 0.3, when dx dt is 50, when y is 0.4, and dy dt is 60, and when h is what? 0.5. It's a 3, 4, 5 triangle.
That's why I got the
Yeah.
wrong answer.
What happened to the 2?
Oh,
I divided. You're going to do this so many times. I divided by the 2 without even writing them down, okay?
okay.
So now, did anybody get dh dt? Anybody?
Yes.
What do you get? What? Where'd the 0.5 come from? The h. is 0.5 when x is 0.3 and y is 0.4. 0.3 squared plus 0.4 squared is 0.5 squared. So dHdt is what? 7 point what? 78. Yeah, that makes more sense. 78 point what? It's exactly 78?
It's exactly
Oh, cool.
78
And it's in 78 miles
per
per hour. And is that, it seems fast, but is that in the realm of reality?
Yeah.
Yeah, they're going towards each other, so it's going to be,
Faster than both cars.
yeah,
Yeah.
you know, it's kind of the way to think about it, yeah.
It's not.
Yeah.
Breaking the sound
Is that okay?
barrier.
Yeah, question.
Why is it?
Ah, so that's a really good question. I was just thinking about this. This is positive, right?
Mhm. Why?
Why is it positive? Well, here's another way to think. The reason this is positive is because we wrote this as 50 and this as 60.
And those are going towards.
They're going.
If 78 is okay because we asked. I think when it says how fast, you can think of it as speed. So it's the magnitude, right? No, you can't. Speed is the magnitude of velocity, right? If you wanted to have this be a velocity, like what's the rate of change of the velocity here? You would have to make it negative 50 and negative 60. And therefore, would this be negative 78? Yeah, it would change the whole thing to negative, yes. But in this case, if it's asking for speed, it's asking for the magnitude of the velocity. The magnitude of the velocity. Yes, Matt, you have a question? Plus, there's a 2, yes, but I'm canceling it. Y dy dt is equal to what?
0.
Is equal to 0, right? Is that correct?
Yeah.
And from this one, what do we know? Dy dt equals what? 6z dz dt. Is that correct? So what could we do with this? We could take this and plug it in right there and know we related. Dx dt and
dz
dt. So either, now here's a key thing, everybody, this is important. We just substituted after we differentiated. What could we do theoretically? Substitute before. Is that always going to be an option? No.
No.
In this case, is it?
Yes.
Yes, because I have y equals, you could literally take that and plug it in, and then you have the relationship between x and z. But sometimes, are you always able to isolate variables?
No.
No. Sometimes, and that's why we learned how to implicitly differentiate, right?
Yeah.
So let's say you had some nasty relationship between x and y that you could differentiate. Okay, that exists. That could happen. What happens if you had a nasty relationship between y and z? Well, you could differentiate that. After you differentiate, you hope that you can do what? Substitute back in, or at least numerically do this. Do it out very carefully. The point is, sometimes you could have more than 2 variables, and sometimes it's not really easy to find the relationship, and sometimes that can mean you have to go from A to B to C to D to get from A to D. But for now, are you guys going to feel really comfortable with right triangle related rates?
Yeah.
Absolutely. Okay, so now, what are we trying to solve for here?
DTB.
How fast is the boat? How fast is the boat? dx dt, sorry, thank you.
You're solving for dx.
dx dt. So I'm going to circle that. We want this one, so what do we have to fill in?
Everything else.
Wait, do we want
Sorry. Yeah, I know. I'm having a conversation while I'm writing this, and I shouldn't do that, okay? So first of all, do we know x?
Yes.
Yeah, we know x is 8, right? What's dx dt?
dx dt.
Good answer. What's y?
1.
What's dy dt?
DYDT.
No.
1.
No.
Oh.
What's
Nothing.
dy dt? 0.
0?
What's h?
Square root 8.
Thank you. And what's dh dt? 1. Can someone tell me where the most common mistake is?
The 0 being a 1.
Yeah. In this case, is y changing?
No.
No, it's not. It's not changing. So what is dy dt?
0.
0. That is by far the most common error on this, besides the root 65 thing. So in this case, dx dt is going to be root 5 over what?
8.
Over 8. So that's about almost what? That's a little bit bigger than... Little. It's a little bit bigger than 1. It's a little bit bigger than 1. That's it. Cool, huh? Meters per second, yes. Very good. Nice. Yeah, that's the answer. That's correct.